So now we've learned about speed and acceleration, or speed and velocity. It's time to learn about acceleration. Acceleration is a rate of change of a rate of change. So it's a little bit complicated, but let's go over it. I'm sure you'll be fine. Acceleration is how fast velocity is changing. How fast velocity is changing. It's mathematically defined as the change in velocity over the change in time. Now I want to call your attention to the fact that it's the change in velocity, not the change in speed. Does that tell you if acceleration is a vector quantity or a scalar quantity? Think about that for a minute. Well, if velocity is a vector quantity, then acceleration is also a vector quantity. So, what's going to be important? Direction. You're right. Let's talk about acceleration in cars. Sometimes we refer to it as the pickup in a car, or my dad used to say how much get up and go it has, or how much get up it's got. If a car goes from 0 to 60 kilometers per hour in 5 seconds, that's a certain amount of acceleration. If it goes from 0 to 80 in 10 seconds, it has less acceleration. Here it went 60 kilometers per hour in 5 seconds, or 12 kilometers per hour every second. Here it went from 0 to 80 in 10 seconds, or 8 kilometers per hour in 1 second. So you see how this one is more than this one. Although 80 sounds like it's more, but we're talking about a rate of change. So how quickly that speed changed, not how much the speed changed, how quickly the speed changed. You could also have a decrease in velocity. So if you're slowing down, your velocity is changing, it's decreasing. That's also considered an acceleration. Sometimes we refer to it as a negative acceleration, and sometimes we refer to it as deceleration. But in any case, whether we call it negative acceleration or deceleration, the car is slowing down, velocity is changing, therefore you do have an acceleration of some sort. It's also acceleration if you're changing direction. Remember, velocity is a vector quantity, so it's speed and direction. So if we change speed, as we just talked about, we're changing our velocity, so we have acceleration. But it's also acceleration if we're changing direction. So if you're going around a curve, you're changing direction. You might not be changing speed, but you're changing direction, so you're considered technically accelerating. Acceleration is based on a change in velocity, not a change in speed. So direction, again, is important with acceleration. So let's take a look at one of my beautiful drawings. This is a car going off a cliff. The car is speeding up here. It has a certain velocity and a certain acceleration. Velocity and acceleration are both in the same direction because velocity is increasing, so acceleration is increasing. With this one, it's slowing down. See, I had him put on the brakes. Slowing down. So velocity is still in this direction. It's less than this one. Velocity is less. But acceleration is in the opposite direction. This is where we get into negative acceleration or deceleration. It's actually slowing down. And finally, we have a car going off a cliff. The velocity is in the direction of the motion. The acceleration is straight down. Acceleration is straight down. It's in the same direction as gravity pulls. Okay, so there's your 3 examples of velocity and acceleration using vectors. Now remember, the length of the arrow is important, isn't it? Because that gives us the magnitude of the vector. What about a change in speed? If we're accelerating in a straight line, then we can say a change in speed divided by the change in the time interval in a straight line. Really important. If you say that you're always in a straight line, that removes that direction piece from acceleration. And then you can say that acceleration is simply a mathematical relationship. If we went from 0 kilometers per hour to 10 kilometers per hour in 1 second in a straight line, then mathematically we can say acceleration was the change in speed. We started at 0 and went to 10. That's 10 kilometers per hour difference over the time, which is 1 second. And this is read 10 kilometers per hour per second. Yes, there are 2 measurements of time because you're taking a rate of a rate. So this is pronounced kilometers per hour per second. And that's acceleration. And again, you can only do a change in speed like this if you're in a straight line because acceleration is a vector quantity.